Hello and welcome to the Minnesota Stormwater Seminar Series. It's so good to be here with you today. My name is Andy Erickson. I will be the moderator for the panel discussion. I'll also introduce our keynote speaker and then let him take it away. Before I do that though, I do want to acknowledge this Minnesota Stormwater Seminar Series is a partnership between us here at St. Anthony Falls Laboratory and the Water Resources Center over on the St. Paul campus, both in the University of Minnesota. We're very thankful to work with them on this seminar series to bring in our nationally recognized experts to talk about stormwater and green infrastructure innovations. So without any further ado, I will introduce our speaker today. This month's theme is assessing ecological impacts from urban stormwater to rivers, lakes, and streams and estuaries. We will start with a keynote presentation by our invited speaker, followed by a panel discussion with local experts on this topic in the second hour. Today, though, our invited speaker is Ken Schiff. He is the Deputy Director for the Southern California Coastal Water Research Project in Costa Mesa, California. Now, Ken actually has a long history in stormwater. He's done a lot of great things. If you're interested, I can share you the 30-some page resume that he sent to me. He's published a lot of papers, a lot of very, very good research papers on stormwater topics. But what I found most interesting is actually the diversity in his experience. Ken has worked in almost every type of professional stormwater career that you can imagine. He's been in academia, he's been a consultant, he's been in his current role for 30 years?
Long time.
A long time. But he's worked in governance and a wide breadth across the stormwater industry. So he has a lot of experience, a lot of perspective on these stormwater topics. So I'm very excited to have him here to talk about assessing ecological impacts from urban stormwater runoff. So without further ado, please take it away, Ken. Help me welcome Ken. Thank you.
Hey, everybody. And hi, everybody online. Thanks for joining me today. And thank you, Andy, for inviting me. It's an honor and a privilege to be here. So my name's Ken, and I'm from Southern California, and I'm from this funky place called the Southern California Coastal Water Research Project, which everybody, just because that's such a long name, we all call it by its acronym SCWRP. So SCWRP. So, and you can find out more about SCWRP and all the stuff I'm going to talk about today at our website, sqwrp.org. And I brought a few of our annual reports, including our last one, specifically on stormwater and how things have changed over the last 20 years in Southern California. So here, I'll just hand this over here, and you can look at them and pass them around if you want. So I started with the title slide because it has a picture that just exemplifies California, Southern California, right? Miles and miles of just completely urban landscape, followed with some foothills, which are typically highly developed as well. And then these giant, 3,000-meter mountains. And that constitutes our coastal watersheds. And of course, nobody can really build on the mountains because they're just way too steep. So I was talking to one of my panel members yesterday, and we were talking about how people love to be active here in Minnesota. And so, yes, you can ski in the morning and go surfing in the afternoon. So I want to spend a couple of minutes talking about the organization, but I'm going to tell you that the agenda today really has two main parts. The first one is I'm going to talk to you about our regional monitoring of our streams and rivers. And, it'll be interesting, because especially the folks that like to geek out on ecology stuff. But the main focus of my talk today is about the kind of tips, tools, and techniques that lead to a useful kind of toolbox for any kind of stormwater manager when you're trying to deal with ecological impacts. And so I'll have that theme as I go through the talk today. So SCWRP, we were created over 50 years ago. We predate the Clean Water Act. In fact, we started right around when the state passed its own Clean Water Act in like 1968, called the Porter-Cologne Act. And a lot of our language from California is what wound up ultimately in the federal Clean Water Act. We're a joint powers authority. And so if you're not a lawyer, you might not know what a JPA is, but that's basically when multiple public agencies get together to form a new public agency for a common purpose. And in our case, the common purpose is to understand the impacts of human activities on the environment, right? Which is something we didn't know before the Clean Water Act really got passed. We just didn't know what the impacts were. And we have two goals, which will be consistent with the theme today about communicating that research and science to decision makers, and then facilitate that science amongst other scientists and researchers and engineers, which is exactly why I'm here today. So here's our list of the public agencies that form us. And, you know, I think we do some pretty good science. We've got almost 50 people. We have about 30 PhDs, and 90+% of our staff have some kind of advanced degree. But I think this is what makes SCWRP unique, is we have wastewater agencies, stormwater agencies, and then the state and federal regulators that oversee them. And these are not small agencies like the sanitation agencies. These are 4 of the 5 largest wastewater plants in the country. And then for the stormwater agencies, these are 4 of the 7 largest flood control districts in the country. So, you know, we've got a lot of people in Southern California. And of course, we have this very kind of convoluted regulatory structure. So it takes both local regulatory folks, statewide regulatory folks, and then EPA folks to help. And so this is what makes SCWRP unique, is the interaction between the different types of dischargers and the regulators. And they get together once a quarter at SCWRP just to hear what's the latest research and how it's going to benefit them in their decision making. So I told you we're about 50 folks. We're all researchers. We don't advocate. We don't make policy. We don't do regulation or enforcement. But we do have research themes. So, and we have 9 of them. And I'm willing to talk about any of these today. So feel free to ask questions about any or all of them. But when we were planning with Andy, and I kind of went through this list with him, he said, yeah, these are the ones I want you to talk about. So great, I can talk about those. So we're going to talk about biology, ecology, and how that fits with our regional monitoring programs. So I'm just going to whet your appetite for a second. So here's Southern California. You can see we're in this lower kind of left-hand portion of the map. And so I'm going to freak out the people online. But really, we're located right about here, maybe just kind of halfway in between Disneyland and Surf City at Huntington Beach. So, and but these are all the sample sites from our regional monitoring. There's over 1,000 in the ocean and over another 1,000 in our rivers and streams. So we're going to leave that for a second and try to orient you, just about the basics of Southern California. So how many of you guys been to Southern California before? A few of you. All right. So we have, almost 600 kilometers of shoreline. And so there's lots of people that go to the beach. And but what most people don't know is we also have a lot of stream kilometers, a couple thousand of them of just perennial, and then 3 times that of our non-perennial stream kilometers. We have many endangered species and that are resident to Southern California, and a huge biodiversity in our fish and invertebrates. But we also have some very designated set-aside areas in Southern California, as developed as it is. We have a lot of national forests, a couple of national parks, and marine protected areas. So it's not all Hollywood and, and downtown LA. You can actually get out of the city very quickly into some natural areas. And these are the things that people worry about when we talk about our regional monitoring. On the flip side, we have a lot of good biodiversity, but we also have a lot of potential stressors. So we have, tens of millions of people there. We've got these multiple highly urbanized watersheds. We have billions of gallons of treated wastewater that get discharged every day. We've got these giant port complexes. We have horrible air quality. So yeah, for all those people that raise their hand, you'll remember that air quality is not great there. It's way better than it was, but it's still some of the worst in the nation. And you sum it all together, and we have about 10,000 kind of water body pollutant combinations on our list of impaired water bodies. So those are all going to require total maximum daily loads, or TMDLs. So you guys all know TMDLs, yeah? Yeah, everybody's shaking their head yes in the room. So hopefully everybody online is also shaking their head yes. So there's lots of work to do. This is a perfect example of one of our mountain streams, right? So in that front picture, and I showed those snow-capped mountains in the back, this is, beautiful kind of riffle pool run type of a system. But these are not we also have streams that look like this on the floodplain, kind of these braided streams with big boulders, right? So these are kind of alluvial fan type streams. This is also a pristine stream. But so one of the things you're going to hear me talk about is how do you assess each of these, and how do you protect each of these, because they're different. They're very different streams, even though they're both pristine. But then, of course, we have some streams that have been straightened and started to be modified. We have some that are just like, throw it all out in the trash. These are going to be ag ditches. So, and then some where they film movies with, trucks driving down this concrete lined rivers. So, in this particular river system, it's probably at least 40 meters from the toe of the slope to the opposite toe of the slope. And this is actually quite full for dry weather. But during a rainstorm, this will go at least half bank full during just a moderate sized storm. And it's super effective at flood control. This thing will rip at about 60 miles an hour. So somebody always tries to raft it, and they rarely succeed. So here's the picture of all these monitoring sites for our regional monitoring program. And I wanted to put it up because it's like, I want to start with the genesis of our regional monitoring program and how do you get these many sites? Because we don't have a big federal agency, EPA or the USGS or one of those come in and just dump a ton of money in our lap and say, hey, let's go monitor. So what we do is what we call coordinated integrated regional monitoring. These are all done by the local regulated and regulatory agencies. And the reason we call it integrated and coordinated is, we'll just stick with the streams for now. This is about 24 different agencies that all have some type of requirement to monitor. They usually monitor right next to their discharge. They've been doing it for many years. Everybody knows what the answer is already, yet they continue to do it, right? Because it's in their MPDS permit, right? In their permit to discharge. And so we got together one day and said, well, I wonder what's happening in the headwaters, right? I wonder what's happening in that watershed that doesn't have a discharge. And so they all got together and said, well, let's just trade off this one site that we've been monitoring forever and it just keeps giving us the same answer. Maybe I don't need all the replicates at this site because I know what it's going to say. And so I'm going to trade off some replicates, or one of my quarterly sampling events, I'll trade off. And so what happens is the regulators give some relief to the dischargers and say, stop monitoring your routine stuff for this short time and spread it out across the entire region. And this is the genesis of this program. So, and that's basically how we get all these sample sites done. And the beauty of that is regardless who administration is in Washington or which administration in our capital of Sacramento, doesn't matter. It's a grassroots organization and we'll continue to do the monitoring regardless of what state or federal funding is looking like. So let's talk about the program and some of the things that I want to thread through today. I'll talk about the results from all those sites, but this is the stuff about those tips, kind of tricks and techniques that anybody can use and why they would want to do any kind of ecological monitoring, kind of at a larger scale. The first is context. Why do all those people, why were the regulators willing to trade off some data? Because it gives them context, right? How does your discharge site compare to every other site in the region? So, and you know, mine the 10 best % of all sites, I'm the 10 worst sites, I'm right in the middle. It's that context that nobody ever has that allows people to start making decisions. The second, of course, is there's economic advantages, right? You, in the stream monitoring, right, you pay for 6 sites, you get over 100 sites back every year. So there's just good economics. So there's stuff about technology development, and we'll talk about technology development, but it's just a great platform to test out new technology or to create new assessment tools, partly because you have this context of the breadth and depth of variability, but also because you have the last part, which is dialogue between the regulators and the dischargers. If you can come to agreement on some of this, does this new technology work? And should we use it to these new assessment tools? This is how we're going to score good from bad. You can have tremendous impact. So these 4 issues of context, kind of technology development, and dialogue will be themes that'll run through everything I talk about today. So we get all these 24 agencies together, half of them are regulators, half of them are regulated. And we say, great, let's do this awesome regional monitoring program across all 2,000 kilometers of our streams. What do you want to know? And these are the 3 questions they came up with in the very beginning, like 15 going on 20 years ago. They wanted to know extent and magnitude, right? How widespread is impact and how big of an impact is it? They wanted to know if that extent and magnitude of impact were changing over time, right? So they wanted to know trends. And then they wanted to know, well, where it's impacted, tell me what's causing the impact, right? And this is where the linkage to stormwater comes in. So with that all said, I mean, pretty standard questions. You guys probably have questions like these in your own monitoring programs. I won't make you wait. I'm just going to give you the answers. So about 75% of our streams are impacted, or at least our stream kilometers. And on the flip side, 25% of our streams are in awesome shape. So you can look at this as good or bad. So definitely have work to go, but also not doing horrible. So, you know, when you saw that concrete line channel, you might not thought that we have as much as a quarter of our stream kilometers. Turns out the trends haven't changed very much at all. And I'll talk about perhaps reasons why. And then the last one is everybody worries about toxics in stormwater, at least in Southern California they did. Oh my gosh, it's pesticides, or oh my gosh, trace metals, right? They're falling out of the sky. And turns out those are not the biggest stressors. There's certainly stressors, and there's certainly stressors in other habitats than our streams. But in our streams, it's really about physical habitat, conductivity, nutrients. Sound familiar? So let's, I'm going to give just a slide or 2 on approach, and then I'll give you some data to support the answers that I just gave you. So, so our general approach on sampling is we use a probability-based design to get us to answers of extent. Are you guys familiar with these kind of random survey type samples? Okay, so most people are shaking their head. So, but for the people online that aren't familiar with this, basically we pick sites at random. right? And any good statistician will tell you you have to do a random subsample to be able to extrapolate to the whole. And so that's what these probability surveys do. We essentially pick river reaches at random, and then that allows us some statistically unbiased estimates of all of our stream kilometers. But of course, not every stream kilometer is the same. So we stratify on which watershed it is, mostly because everybody wants to know how their watershed is doing. We stratify on stream order, which kind of gets us that high mountain stream versus those floodplain streams that I showed you in the picture. So, and then we measure a bunch of different things. So, and I'll talk about some of the things we measure today, but not all. So feel free to ask me anywhere along the way. Go ahead and ask. The second part of the approach that I want to talk about is how we assess the data. I talked to you about how we collect the data, but here's how we actually assess the data. We use these indices of condition. We have one for invertebrates. We have one for algae. We have one for physical habitat. We have one for riparian condition. These are super useful tools. Now, my understanding is here in Minneapolis, you guys have an index of biotic integrity. Is that true? So these are kind of like an IBI, but not really. So we use more of a multivariate approach. And so this is more that kind of observed to expected ratio. And for the folks online that don't know what this is we have collected enough data at sites that we consider reference that don't have human impact with them, that if you can put in certain physical factors like size of the watershed, how much rainfall in this area, basically on average, the slope, the latitude, you can pretty much predict what should be living in that stream. And so then you basically go out and measure what's living in that stream. And this is the observed to expected ratio. What you observe to what you expect, the closer it is to 1, the better this stream is doing. The further and further it is below 1, not so much. And then, of course, you have to hit cut points for what constitutes good and bad. So the reason I'm bringing this up is because it starts to illuminate some of those 4 things I talked about at the beginning, right? Some of the technology developed. These things did not exist when we started. So we had to do the technology development to get to these indices. And we couldn't have done it without all these different agencies interacting, right? Because it's one thing for Ken to go out and develop these indices and everybody say, gosh, Ken, I didn't like the answer at my stream site. So obviously your index is wrong. So, but if I do it with all the agencies together, collaboratively as part of our regional program, all of a sudden, oh yeah, that index works pretty good. So, and so they're more willing to accept an answer when it doesn't turn out the way they'd hoped. So, yeah, so each of these are actually a talk unto themselves. So, and I have some resources at the end of my talk where you can go look up the papers and stuff associated with each of these. So, the last thing to know is that there's 4 possible outcomes for each of them. You can either be intact, which basically you're in a reference kind of an envelope, or you can be possibly altered, where you're kind of on the tail of what a reference is. You might be referenced, you might not be, and then you get worse from there. You're either likely altered or very likely altered. You're not even close to the envelope of reference condition. And so 4 categories. And the reason this is important is because these narratives are what the managers understand. And so this is kind of that dialogue that I want to continue to kind of harp on. So here's actually the number of each of those 4 indicators that are in good condition. And basically, if it's 0, you know, if none of your indicators are in good condition, you can pretty much agree that's not a good site, right? If all 4 are in great condition, then that's probably a really good site. And if you're somewhere in the middle, then you have to make some hard choices. Excuse me. So I'll let you look at that map. So there's two ways to look at this. The first one is, I'm going to walk over here again. Most of the blue are actually in those coastal mountains. Remember that first picture I showed you on the title slide where the snow-capped mountains? You can see most of the good sites are in the mountains, and most of the ones that are kind of in that red are down on the urban floodplain. So, you know, no great surprise. One would have expected these types of things to happen. The second way to look at this is it doesn't matter which of these watersheds you're in. There's always some sites in bad, and there's always some sites in good. So everybody has work to do, but somebody also has sites they need to protect. And I guess this might not be quite as relevant to you, but because you may or may not know these watersheds, they kind of arrange from, on the left is our southernmost sites, and it goes from south to north as you move to the right. And it's just a heat map of stream kilometers in good condition. And the main thing that I wanted to point out is that the element of context, right? I told you about the 4 things I was going to hone in on. This one is all about context, right? So you might be, you know, if you're in Cayugas Creek, the third from the right, you're like, oh, criminy, I'm the worst. I probably need to do something, right? If you're Ventura River, you're thinking you're doing pretty good, even though you're not great. So context makes a big difference. Here's the second question on trends. I'm sorry, yeah, this was the second question on trends. And the answer I gave you is, yeah, not much. And you could kind of squint at this and say, maybe things are getting a little better, but statistically, they're not. So this is over the last, 10 years or so. So, and it's continued to be this way. And this is despite hundreds of millions of dollars in stormwater infrastructure being constructed and implemented in these coastal watersheds. And so when I was having dinner with Andy last night, I asked him the question, do you have any receiving waters like streams where you've done some big watershed implementation and you've shown an improvement, in the river downstream? And he's kind of like, yeah, maybe this one place. And I'm like, great, tell me about it, because I've been asking people all over the country and I haven't heard of one yet. That would just from stormwater infrastructure stuff. So I'd love to hear that maybe over the panel discussion. I'm going to pick up the pace. And the third question was about stressors, likely stressors. And so here's an attributable risk plot with different types of stressors on the y-axis. And they're kind of color-coded by what kind it is. But basically, the further to the right you are on this plot, the more extensive the risk is. And you can see that things like toxicity, copper, pesticides, there's not much attributable risk to those. But as you go, things like conductivity, in our case, not so much phosphorus, but more nitrogen, because we have nitrogen limited systems, and physical habitat, like habitat diversity. Those are the things that are driving our impacts on a regional scale. So now that I've kind of given you, there's context, there's dialogue about what's our biggest stressors, a lot of it's physical habitat, it started generating conversations about biological expectations. All right, I'm not meeting, my biology isn't great, but here's that original mountain stream I showed you early in my talk. Here's another stream in the middle, which is basically an ephemeral stream, which also qualifies for regulatory guidance, right? How do you judge that? Obviously, you don't expect biology to be the same in those two. And what about the concrete line ditches, right? What do we do with the biology there? So do we make them rip up all the concrete? What do we do? So One of the things was how good can the biology get? So we went back to all those triangle sites that you'd seen on that big map with all the dots where all our sites were. And we plotted the CSCI, which is our invertebrate tool. And we divided it between sites that were completely natural, like the mountain stream I showed you, partially kind of converted. Maybe it's got rock levees, but it's got kind of a natural bottom, and then fully hardened, entirely concrete. And these are box plots of the scores. And so the higher the score, the better it is. The dashed line represents what we perceive to be the break point between good and bad. And you can see that if it's natural, most of the time it gets it. Maybe there's other stressors besides the hardening. But when you go to the entirely hardened site, I'm going to move again. So none of these sites ever make it above the reference line. And so saying we need to make a concrete line channel into a mountain stream or a pristine reference stream, it's not going to happen. So, but you could look at something like algae, and maybe some of those best streams are going to be able to make it above the line. There's just other stressors here that are preventing it from moving up. So it's about setting biological expectations. This is the dialogue part of the thing that I was talking to you about. The last part is about translating our science to managers, because managers typically aren't scientists. They're certainly not ecologists. And usually when you have super complex data, like I just showed you, they just kind of go, I don't know what to do with that. So how do we make it into something they can understand? We use this thing called the Stream Quality Index, which we've created a web app, and I'll give you the web link at the end of my talk. But it's basically a stressor response type of a system where the top half is about responses and the bottom half is about stressors. And then we do big mashups along the way. So we have to mash up bugs and algae, and then we have to mash up chemistry and physical habitat, because I told you those were our two biggest stressors, right? With the chemistry being nutrients and conductivity. And you come out with some type of guidance like this. And so this is just a 2x2 matrix with kind of biology on the top and stress on it as different rows. And you know, when you put those combinations together, like where there's low stress and healthy biology, you know, that's a healthy unstressed stream, and that's great. And these make sense, right? Hopefully this is making sense to you guys. So the trick is translating that into what a manager is going to do. That's what the blue letters are here, right? And so obviously, if you're impacted and stressed, you have to do some type of restoration, or you have to make another decision about, I'm going to keep this a flood control channel and not call it a stream. So once again, this is the dialogue that you get with the regulators and the dischargers together in the room, designing, running the program, and agreeing on what they're going to say before you even go out in the field. So we're running lean on time. So I want to go straight to this one, which is about these biological expectations and what you're going to do with the data once you have it. And so, I'm going to zoom in on this part of the app, which looks something like this. So you have all these sites that are impacted, right? I said 75% of our stream kilometers are impacted. What are you going to do next? Which one do you pick first to go do something in one of those 4 boxes? And this is the thing we came up with. We developed a landscape model, kind of a landscape scale model that says, kind of like with that, our bug thing with the observed over to expected is what do we think is the best this stream can be? And that's essentially what this bar is. Because you can have different types of streams. And this bar represents, this is the range of what we call the CSCI, or our bug index. That's about what we see. This is this is that box plot that you saw in the previous slide. This is the range. And then what we do is plot on it what your exact site is. And so we go, in this particular instance, this site is probably about as good as it's going to get in a highly modified stream. there's no sense in doing a lot of work here unless you're going to start ripping up concrete. There's so there's nothing you can do with the water quality, the nutrients, the conductivity, those kinds of things. As opposed to if you go to a next site, maybe it's even up here on the kind of good end of the scale, but your site falls somewhere towards the end of the bar. There's probably still things you can do at that stream site that'll make it better. Managers can understand this. So this is the last place we're going. We're taking it to the next level because I'm doing these kind of we started very regional, and then we went regional stressors, and then we went with kind of regional condition estimates and where you fall along the regional condition. With the managers, once they decide, oh, I'm at that part on the bar where I want to do something, what is the thing you go and fix? And that's what this is, what we're calling rapid causal assessments. If anybody's done a causal assessment before, it's a very laborious, expensive, takes a lot of time. Yeah, I see a couple of people shaking their head. We want to, with the regional program and the context of what a site could look like or should look like and what the stressors are that might be changing it, we now have it down to something close to the push of a button. And it looks something like this. On this top plot, you can look at all the times that this site's been sampled. And in particular, this site was looking pretty good back in the early 2000s. And then by the time you got to 2009, 2010, it had degraded. And then if it was in poor condition, then you can start looking at different stressors. And so for the folks kind of in the back of the room, these are lists of different types of stressors. And then what the color block means is, was it in good condition? Yes or no, right? And then if it wasn't in good condition, what's the likely stressor? If it's green, then you kind of go, there's not really conclusive evidence that this is or isn't the stressor. And of course, in 2001, the site was barely, but it was right on the borderline. So you couldn't tell. But as it got worse and worse over time, once it turns red, you go, this is definitely a stressor that could be impacting the biology there. And if it's blue, equally as important, this one definitely is not a stressor. So you can use the causal assessment to rule things out and to rule things in. And so this is the thing that stormwater managers really hone in on. All right, so I gave you the answers to the 3 questions. So, and we talked a lot about context. We talked a lot about technology development, like those indices, and those new, and then we also talked about dialogue and the interaction between the regulators and the dischargers to really move things forward and make an impact. Here's the list of the other regional programs that we've got going. We can talk about all these as well, because we have those same 4 concepts on all of these. But I want to point out the top one, which is about stormwater best management practices. We're starting that right now. And so the folks online or in the room, we're hiring a research engineer right now to help us with that program. So if you're interested, I'll leave my email up at the end. Please contact me. So this one's going to be really exciting. By the time we're done, it'll probably be one of the largest BMP monitoring networks in the country. And here's some things to go look up, like the SQI web app and the publications for all of the indices that I showed. And with that, I'll conclude my presentation.
Very good. Thank you, Ken. What questions do we have for Ken from the audience, both online and in person? Maybe I'll start with one of mine. So Ken, you mentioned the no time trend over the last 15 years, and you showed us the data that kind of supports that. My question is about what has happened in those watersheds over the last 15 years, both implementation on the contributor side, developments, things like that, and implementation on the treatment system side, BMPs or other kind of things. Are both of those things happening? Are one or the other?
Okay, so that's a great question. And of course, I showed you at the grand watershed scale on that. So, but when you actually start diving into the watershed by watershed or site by site, we actually have some of that data as well. And what it really comes down to is about 50% of our sites or our stream kilometers are just not changing. About 25% are improving, and the other 25% are getting worse. And so it turns out that the parts that are getting worse are where there's a lot of development, and the parts that are improving could be the stormwater management measures. It could be just, we're in droughts, there's not as much stuff running off, but it's not always the same sites in the 25% from year to year. It can shift, And so that being said, Southern California is literally investing hundreds of millions of dollars into stormwater management, like structural controls and non-structural controls. And at least up to this point, it's not making a difference. So
at least it's not getting much worse.
So it's like you've been in our meeting. So.
What other questions? Oh, we got a question here.
Thank you for the presentation, Ken. That was very interesting. Can you give an example of how climate change factors into your assessments?
Yeah, so we talk about that a lot because I told you that about a quarter of our stream kilometers are perennial or close to perennial, but 3/4 are ephemeral. And at least the way the climate change models are predicted now, after we downscale them to our region, we'll probably have fewer storms. It'll probably get a little drier, but the storms we get will be much more intense. And so we have these things called atmospheric rivers. I don't know if you've heard about those, but yeah, it's basically the jet stream just kind of parks over and just dumps for a while. So, so we have 2 or 3 concerns associated with that. The first is how well our BMPs are sized moving into the future. So even if they're working now, will they work, 50 years from now, or even 20 years from now? The second thing we worry about is which streams are going to dry up. And specifically on this one is on water utilization. Because we're moving into a drought system, more people want to capture and use stormwater, which is a great thing, except for that means less water in the creeks. So it might even accelerate the drying of our streams as people try to capture and use that stormwater. So there's when I showed the list of all of our different research themes, one of them was eco-hydrology. And after going through the hydrology lab here at St. Anthony Falls, I'm glad I didn't present on that today because I wouldn't be able to keep up with all the hydrologists in the room. But I'm glad to chat about that, of course. The third thing that we worry about in climate change are harmful algal blooms. And I know that's an issue here. But yeah, blooms like it hot, and the warmer it is, and especially if we're lowering water levels, we expect the harmful algal blooms to get worse. And we've already started to see that in Southern California.
Yeah, Ken, you showed the matrix that where you would identify different sites for reference for, I think what you called rapid causal assessment.
Yep, I'm going there.
There we go, or restoration. I guess it's easy to see how the monitoring program that you have would identify a reference reach or be useful for doing the causal assessment. Do you feel like the monitoring program that you have is effectively informing restoration projects? You mentioned like all of the stormwater projects that you're doing. Is this information being used well for that?
Yeah, so that's a great question. And we're actually implementing this matrix right now. I'll call it more on a pilot scale, is each of the agencies that are participating in the program are taking 1 or 2 sites and working through this matrix and including the restoration piece. And so and this includes not just the dischargers, but also the regulators, because they have some stuff of their own they have to do, including some of their own monitoring. So, and they're the ones that ultimately approve every restoration project, right? So they can direct restoration to happen where they want it to happen. So, so that kind of gives you the background to your question. And then the direct answer, which I think you were asking, which is the restoration actually helping? And the answer is, we don't know yet. So I've seen many where it doesn't work at all. I've seen a couple where we think we're seeing some positive. It just doesn't happen right away. It takes a few years. Some of them it happens and we're worried that they're what we call biological islands or biological deserts, right? It's just too far from another site that can provide spawn for the site we're in. So there's a lot of challenges to see what's going to make the restoration work. So, and I think part of that, one of my themes was dialogue and communication. And I think part of the problem is we don't have all the players at the table, because the folks who do the stormwater and the water quality regulators have some authority there. But there's also our natural resources group that really aren't at the table as much. And they're also the ones that have stuff to do with restoration, what they allow as a legal restoration thing. Was that helpful?
We're going to take an online question, then we'll take another in-person question.
How do you integrate the 4 indices to come up with a condition assessment overall?
Yeah, so thank you for whoever did that online. It looks like this. So, so here's our overall, yeah, I went through this really rapidly because I was trying to save time for questions. So I'm glad somebody asked that. Our overall sediment quality index score winds up here, and it's categorical in that 4 plot, right? It's not a number. And that's because managers, they like narratives more than they like numbers. So, and the top half is our response, our biological response, and the bottom half is stressors. So thanks for following me on the camera. So, so for the response, we have invertebrates and algae, and then we have to mash those up in some kind of biological condition score. For what it's worth, that is done with creating probability plots of biological condition, and when one's good and when's the other's good. So I'm sorry, this one is done strictly with the indices, and you saw the dashed reference lines. That's how this one's generated. For the stressors, we had to mash up different types of chemistry, nutrients, conductivity, because we saw those were the biggest regional stressors. And then the physical habitat, which is our riparian condition and our in-stream physical habitat. So these are based on probability scores. We know, because we have biology, we're able to plot the probability of good biology or bad biology for different levels of each of these. And so you get a probability score for both. Then we can mash up the different chemistries by doing a multivariate probability plot. And the same thing with the physical habitat. And then we'll essentially, in our stress condition, we just make it an additive term for these two. So, and then these will essentially go into and we basically do a stress cutoff, probability cutoff of 50%. So that's how that goes. Cool.
One more question about working with stakeholders. You mentioned how you use leverage to get more data through these sites. Can you give us some examples of some of the challenges
Gotcha. So they all want to work together, but how do we actually make it happen? So yeah, so you're saying that basically once they buy into the program, the actual logistics of making the monitoring happen? Okay, that's a great question. And it's where we spend a lot of our time. So if you're going to have 24 agencies working together, collecting data that you want to mash up all at the end, right, and integrate all at the end, it all comes down to a really good study design so that everybody knows where they need to go, and then a bunch of quality assurance to make sure they're generating comparable data. And so, so the study design, we spend a lot of time going through the details of the questions, and then we'll generate study designs for them. The biggest challenge with that is it's probability-based design. So sometimes it winds up in places they don't really want to go to. So it might be a long hike, it might be on private property, might be in a spot they think is not great. They'd rather go to the other spot that looks great, and we don't let them. So, so that's kind of the logistical challenges on the design side. On the comparability, the QA side, we do a lot of training. So we do QA before, which is usually training. We'll do some audit while it's in what we call in-life audits, right? And then we'll do post-monitoring audits, usually on the data types, range checks, those kinds of things. On the taxonomy, on the biology, we'll do round robin splits on samples. So we'll get like second taxonomists outside that agency or outside that lab looking to make sure the ideas were okay. And now we're starting to move to eDNA, which might be a great conversation piece for the panel discussion. So, and that kind of takes away a lot of the taxonomy concerns. The last part on the integration is data management. It turns out that might be actually the harder than the design and harder than the QA comparability stuff. It's how do we manage all that data? And, but we do, I didn't put the website up here, but I can send it if you really want to see it. You can actually now go access every single piece of data for every single site going back for the last 15 or 20 years. So we're lucky. Esri has a headquarters not far from us. So we're an Esri kind of beta test center. So that's kind of nice.
Okay, we'll take one more online question. Please.
One of our online audience members asked that in their watershed, also a joint powers board, that they face high expectations in areas where they have both sensitive species such as trout and modified stream tributaries. Did you experience a case where you had to balance sensitive species with habitat and physical limitations when setting expectations for a stream reach?
Yeah, that's a good question. So I told you we have about 24 threatened and endangered species in Southern California. And that really has come to the forefront. I mean, we have difficulty even sampling those reaches. So lots of times they won't even let us, do kick nets in those sites. So, so there's that type of challenge that you need to get over. Where the conflict usually comes in is people want to kind of go in and especially in California and really Southern California, I don't know if you have it so much here, is we have these non-governmental organizations that are very active and sometimes quite litigious. And forever how much people are frustrated, they make stuff happen. So, and so they're the ones that push strongly on this. So to answer the question directly, it helps in two ways. This is how we overcome this struggle and this kind of discussion when we're in these groups with people with different agendas. The outcomes have come twofold. The first one is doing set-asides. And I don't know if you guys are familiar with 30 by 30. So that's, it's a federal goal, but it's actually now a state policy in California. 30% of your area set aside for basically wild lands by 2030. And in California, we've done it in the ocean already, and they're trying to do it on land, right? Which would include streams. So so I'll just leave it there. That's it. Yeah.
That's great, Ken. We'll move into a 5-minute break as we set up for the panel discussion. So please come back in 5 minutes. But in the meantime, help me thank Ken for the keynote. Welcome back to the Minnesota Stormwater Seminar Series. I'm excited to be here with you and start our panel discussion. Again, my name is Andy Erickson. I'm here at St. Anthony Falls Laboratory, and I'll be moderating the panel. We have our keynote speaker, and we have 3 local experts. I'm going to start the panel by introducing each of them and asking for their relation to the topic, and then we'll dive into questions. So for the online audience, please continue to post your questions in the Q&A chat. We'll also take a few questions that were left over from Ken's talk as part of this, and then in-person audience, feel free to ask questions once we get through the introductions. So I'm going to start on the far my right, your left side, with our first panelist, who is Matt Kocian. Matt is the Lake and Stream Specialist at Rice Creek Watershed District. So Matt, from your perspective and experience, how do you relate to this topic today?
Sure. Well, it was interesting to see Ken talking about a watershed that spans something that's very urban to very rural. Certainly the area you're working in is much larger than the Rice Creek Watershed District. We're about 186 square miles, but we span a similar gradient of human disturbance like that, with the southern part of our watershed being very developed, the upper part of it being less developed. And so managing a monitoring program over that gradient, there's some similarities there, and that was interesting to see. It was also really interesting to hear about how in Ken's organization, they've melded together some of the different assessment tools. So for physical, biological, and chemical, certainly all of those assessment tools exist in Minnesota, but I'm not sure that they're so formally integrated as you described in your program. So that was really interesting to see.
Very good. Thanks, Matt. Our next panelist is Hong Wang, who is a principal environmental scientist at the Metropolitan Council. So Hong, from your perspective and experience, how do you relate to this topic today?
Oh, yes. Really interesting to listen to Ken's presentation and about the detailed assessment of biological community and the water quality. And I like Andy said, I'm environmental scientist, work with Met Council, and the Met Council is a regional agency and work on the now environment service, one of the decision for Met Council. We collect not only, of course, this division not only collect sewer and treat wastewater for Twin City area, but we also collect a sample every week. We go out to collect a sample from the lake and from the river, from the stream, and then we're doing some kind of assessment. So my job is to work on the water quality assessment, and my background and many years ago was work on the watershed modeling, use watershed model, try to figure out how the stormwater surface run off and bring the pollutant to impact our system or stream. And the recent 10 years, we work on water quality assessment, some kind of trend like Ken said, and how the water quality change over time. So recently we did 3 major reports, and one is a comprehensive assessment of stream in the Twin City metro area. And also 5 years ago, we finished comprehensive regional river assessment. This including major parameter, traditional like a biochemical and also including chloride. So the results is very interesting. We found due to, like you say, we have a lot of investments in the BMP. We found most parameters, including nutrients, TSS, biological, like already substantially improved, go down trend. And but nitrate still stable, increase, some increase or reduced, but only we found one chloride continuous increase in region, because as I think a lot of urban development population increase, so increased use of salt, especially in the winter, de-icing salts. That's why recent 5 years we initiate another project to assess and regional strain, how chloride change, how contribute to our river. So no exceptional, we assess about 18 strain. This 18 strain chloride continue increase. Only one Cover Creek just stable. So actually this is from stormwater, from the especially winter and the icing from the impervious. So this is really interesting. So a lot of story now we found, and we have, maybe we discuss later, we have several 3 reports to be available for public. This result actually attract regional attention and also immediate interview and also national attention too. So we can discuss later. Thank you.
That's great. Thank you. That's very exciting. So our next panelist, we have Jessica Kozarek, who's a research associate here at St. Anthony Falls Laboratory.
Great.
So Jess, from your experience and perspective, how do you relate?
Okay, so my background is in chemical and biological systems engineering, but much of my research falls within ecohydraulics, or looking at the relationships between water flow, sediment transport, and aquatic biota. So for example, how do we restore physical habitat? So one thing I found really interesting about your talk this morning is that, you know, from my perspective and in my realm, a lot of times we talk about the limitations to what you can expect by restoring physical habitat alone. So that integration between what's happening in the in-stream physical habitat and what's happening with stormwater and water quality as a whole. I think that was really fascinating. Here at SAFL, I manage the Outdoor Stream Lab, which, if you're not familiar, is a field scale outdoor laboratory. And that allows us to conduct controlled experiments on interactions between physical, chemical, and biological processes. So it gives us the capability to test things like stormwater best management practices, such as some of the work that Andy Erickson is leading, but also to test the response of stream and floodplain processes to things like changes in hydrology, sediment transport, water quality. So in a controlled environment, test the response to what you might expect from management activities, such as stormwater management. So an example of that over the last few years would be work that we've done looking at the response of freshwater mussels to flashy flows and increased sediment loading. So I'll leave it there.
That's great. Thank you very much, Jess. I won't ask for Ken's relation because we had him set up our keynote talk today. Thanks, Ken. So I'm going to dive into a question here, and then obviously we'll open up to questions for our online audience and our in-person audience. And I'm going to start out with an easy one. So our topic today, we looked at assessing ecological impacts from urban stormwater runoff, right? So I want to know from our panelists, our local panelists, what are the lessons that you've learned in your experience trying to connect water quality data and field measurements to the impacts we're seeing in our water bodies? What have you learned in that realm, trying to tie those together and then explaining that to others? And anybody can dive in.
I can jump in first there, Andy. I think this was alluded to in some of the questions, the notion of climate change. And I think I heard Ken talk about how they're expecting in the future to see less rain, but when they do get rainstorms, it's more intense, higher runoff. I mean, what we're seeing, I think, in the impact on a lot of our systems is that, yes, it's based on, overall stressors that we can quantify in the environment, but the impacts are being felt more so in these periodic storms that are really having a major impact on the systems. So, 8 inches of rain in 24 hours can completely destroy a habitat in a stream system, and trying to restore that back to what it was before takes a really long time.
That's a great response. Others?
So I think sample collection is very important for our watershed ecological system. And we Met Council collect a lot of sample, and the longest one more than 40 years. And we learn a lot. So data collection, how to transfer to readable or understandable what it means to our system is very important. So We learned we need do really good assessment, especially like Ken did, what's mean, and also we did use now we use a USGS and the QW train. This train technology is very good. Actually, you know, when we have a stormwater and dry year, wet year, and you don't know how much pollutant go into the system and what is major impact. But these tools remove the impact of flow and variation of annual variation directly linked to our concentration load to the source. This means we can use this information to help our DMP. So how we made a lot of investment. What's the effect of investment? So this job actually why regional people, decision maker like our job because we provide direct information. So we learn this assessment. We need a good tool, good methods, good data, and also good people too. So yeah, so we learn a lot.
Great.
No, I don't know what else I can add to that.
That's fine.
So.
Yeah, no, that's good. We're gonna let's take an online question. Maybe if there's a good one from Ken's talk that might be great for our panelists, we can pull in one from online. If anybody in person has a question that we want to ask of the panel right away, we can dive into that too.
So one of the questions from earlier was, so if all of the efforts in the past 15 plus years don't seem to be reflected in overall improvements, why bother? Do we need to completely reassess our approach to water quality improvements? What might we be missing in our command and control approach to stormwater management?
All right. Okay, what do I say to that? It's not working, so give it up. Well, I guess my first response would be Andy's comment. At least it's not getting worse. So, which is a start. So we actually had this conversation last night that at least in Southern California, you know, before it was urban, it was ag. And so our watershed, and before it was ag, it was Native American. They also, you know, did their landscape modification. So landscape modification, stream modification in Southern California has been going on for hundreds of years. So, so you can't expect to change hundreds of years of modification in a decade. At least that's what our conversation, or at least, you know, should we expect that much change? I think the thing that Southern California has going for it, and I don't know how it works here, but because we have these really steep erosive watersheds, we also have lots of things like wildfires. Our systems are used to major disturbance, and they recover because they're designed that way. You know, nature has designed it that way, and so that's what gives me hope to continue to move forward. I think the problem in the questioner's statement is this command and control concept, which we can do what we can, but ultimately nature is the one that makes the decision. So that being said, there's some great experiments that people are trying, and if we want to talk about that more, we can.
So maybe from our local experience, you know, we've been collecting data, we've been looking at assessments and trying to understand impacts to our streams and understanding how these things are changing over time. Are we being encouraged by what we're seeing that we should continue doing what we're doing, or give it up, or do something completely different? What would you say?
I'll be glad to answer again.
Go ahead. Yeah.
All right, so one of the things that I alluded to as one of the research agendas that we have at our agency is ecohydrology. And because we've had so much modification, we're now facing choices about not necessarily returning our stream to what it once was, this kind of meandering floodplain kind of stream, because there's not much of a floodplain left anymore because we've had so much development. So the real questions they're asking now, especially if we take that command and control concept, is what do we want the stream to be? And through ecohydrology, we know how to control those flows to establish habitat for different types of species. And so, yeah, if we want kind of a willow-based system, we know what kind of flows we need for that, right? If we want a salmon-based system, we know what kind of flows that's going to take and what kind of habitat. And those are the questions we're starting to ask now. And mostly because of going back to the comment about climate change is, okay, we're going to capture this much water, but how much water are we going to release? When are we going to release it? And so that's how I would address it, is not that we change or not that we're going to improve but what do we actually, we're at the stage where we can design it what we want it to be.
I might add that, you know, the talk is about ecological health, and the response of an ecological community might take longer than some of the physical or chemical variables that you could measure in a monitoring system. I heard that term biological desert. I thought that was interesting. I don't know, we'd use the word desert in Minnesota, but certainly habitats are fragmented. And when we do restoration work and perhaps have an expectation to see, you know, restored ecological health in a short amount of time, given that the systems are fragmented and where are these sensitive species going to come from? Yeah, have to adjust expectations there, but it also, I think, highlights the importance of looking at all of those variables in your monitoring system and saying, we have improved the chemical sides of things here, the physical components, and it's just going to take time to see the ecological response.
Other thoughts on that? Maybe I'll dive a little bit deeper. Do you have a question from the audience? Yeah, we'll take one.
I have a question for the whole panel. What sort of new technologies and techniques would be most useful in this type of natural resource protection and restoration?
To me, I think management is very important. Technology, of course, can improve, can recover our system back, but to me, it's almost impossible. A few years ago, I'm as an advisory committee member for the federal U.S. Army Corps project in the Minnesota River Basin recover. One of topics to compare with the European pre-sediment condition. It's a good idea, but how impossible for human change our environment. So what I mean is management is very important. For example, and the chloride make huge impact now. People not really pay attention, use salt area, but chloride is a permanent pollutant. As soon as enter water, you cannot remove. We have no technology to remove now because cost is high. So what we can do? Management. When people use salt, how you management? This is really from the basic methods to me is good. But of course, other technology, we need to develop new technology. It's very good for our environment, of course, but to me, priority is management.
Yeah, and I definitely want to come back. All right, but other answers to the question.
So, you know, it's a very broad question that our technology and techniques have been improving dramatically. You know, and we have all kinds of new remote sensing techniques. We have drones, we have ways of measuring topography and vegetation and things that we didn't have even a decade ago. So there are all these new technologies, new modeling, higher resolution things that we can use to help us inform how we deal with our streams, as well as in newer techniques and methods for the stormwater treatment. But I like what you said about management and still recognizing that part of that is not focusing on one picture, but looking at the whole picture and how all these pieces kind of fit together, whether that's the stormwater in the stream or whether it's how people's actions affect the overall chloride concentrations.
All right, so just to make sure I have it clear, was your question about the technology on the restoration, the technology on the water quality control, or the technology on the monitoring?
Yes. Yes, it was broad. So touching on any one of those and kind of thinking about the technology that we don't have or the techniques that would be really helpful that we haven't implemented. So if there was a simple way to remove chloride from the water that was cheap and easy, that would be great, but we don't have that. So yeah, management.
Okay, great. Well,
A
I'll
wish list.
Yeah, well, I already kind of gave you during my talk the answer to the restoration side, which is at least from the Southern California or my personal perspective, we still have a long ways to go because I haven't seen anything definitive on it, at least in our types of river systems. So I'll go to the second one, which is on the water quality control, because we have a very active program. You saw in our research agenda that we have at our place that stormwater BMPs are a huge part of that. For what it's worth, it's one of the main reasons I said yes to Andy about coming out today, because they do such great work here at SAFL. I mean, it's literally nationally, internationally renowned work. So for the folks that aren't familiar with that, that's why I flew across the country. So the third part on the monitoring, the new technology is what gets us super excited. And that's why these regional programs are so awesome, because it's this great platform where you're doing all the traditional measures at lots and lots of different places or times. And so you can layer on top of that the new technology to see how it compares. You know, is it really, truly better, faster, cheaper? Or does it work kind of okay in some places, but not others, right? Or is it work great, but it's so complex, it's really just a research item. It'll never be, you know, an everyday item. So, and so the one that I'm going to give you so you can hang hope on it is this thing called environmental DNA or eDNA. And Justin and I were talking about that last night. And so if you're not familiar with it, if you're not familiar with one of the folks online, is everything sheds DNA, from microbes to plants to invertebrates to vertebrates, including humans. And we're shedding DNA all the time. And, you know, when we collect one of these samples, let's say one of the algae samples, it can take a year and, you know, $1,500 to run one of those samples, to have somebody sit under a microscope for hours and hours trying to identify every single piece of algae, you know, every organism in a sample. Yet that is what the state is relying on for our biocriteria and our new nutrient criteria that's about to happen. So how do we make that? I mean, even if you could afford the time and the money with all those samples, there's like 2 labs that can do that in all of California. So there's no way they're going to be able to keep up. So environmental DNA is this new technology that's come around just in the last few years, where you literally scoop up some water, send it off to the lab. They'll concentrate the cells, they'll extract the DNA, and then they'll send it to one of the next generation sequencers for very highly conserved parts of their DNA. And if you have a library for all the different organisms that live near you, whether those are the threatened and endangered species that came up in the earlier question, whether that's an invasive species, or whether it's just the host of organisms that you'd like to find in the expected over the observed to expected ratio. And you can get all that for under $100 in like 2 days. So it's very cool new technology. And we've done enough work to know that we're not very far away from like a commercial rollout on that. We won't do the commercial rollout, but it's there. The technology is available. So.
Any other thoughts? Any other thoughts, comments on technology related to this topic? Oh, we have more questions from the audience. Yeah.
Okay, I'm gonna go back to that hot take question from 2 questions ago. So maybe this is 3 questions attempting to combine them all in one, which is, we know environment's resilient to some degree. What exactly is the goal of restoration when ecologically things have been changing over time? And second question, or a sub question, will be, how do we balance the adaptation and acclimation of the biological organisms that's within the system with this like human development and human stressors? And to which point can we think about, like, I feel like sometimes as engineers, we have this attitude that we can change it all and control all of it. But like the plants, if they don't want to grow there, they're not going to grow there. Like if there's invasive species that'll do well in the area, they will do well in the area. So that's kind of where I think, I don't know where my question will go after that. And then the last part of it will be like in terms of impacting on like the overall water resources in Southern California and also everywhere. How do these ecological restoration contribute or work together with things like reclaimed water treatment and like these like enhanced wastewater treatment to actually provide more drinkable water for human use?
That's not a big question at all. Who wants to dive into that?
Okay, only because you were kind of asking about in Southern California. And so let me give you the Southern California perspective briefly, but I'll be curious to see what my other panel members say. So, so we're big on recycling. We already do a lot of recycling in Southern California. In fact, where I live, which is about halfway between Los Angeles and San Diego, they have the largest water recycling for what they call indirect potable reuse anywhere in the country. So it's actually pretty impressive. You know, they'll let you, you know, they'll give you tours of the plant and stuff. So yeah, basically I drink recycled wastewater that they put in the ground and then pulled back out. So, so the issue that we have with water resources is not whether we can recycle it, because that technology has been proven. It's where to put it, right? I told you that our treated wastewater plants are, you know, 1.5 billion gallons every day. And we just don't have a ton of aquifers, or at least a ton of aquifers everywhere across Southern California. So they can recycle the water, but we don't know where to put it. You know, if they're not going to use it every day. So, and then of course, the next part of that is, where do we get our water originally? So it used to be from the Colorado River or from San Francisco. Of course, they're both growing quite a bit themselves and running out of their own water. So they want to keep as much as they can of their own and give less to us, or at least not let us steal as much. So we have to find new sources of water. And those all I talked about during the question and answer session, that our eco-hydrology, and that we're starting to use stormwater reuse more and more. The other is we're actually starting to desalinate water, pull it from the ocean and pull all the salts out and use that. But that has its own ecological impacts, of course. So hopefully that answered your roundabout question, or at least teed up my other panel members.
The first part of your question, I think you were asking about, you know, what are we restoring systems to? What is our goal for each one of these systems? I think Minnesota's gotten better in the last decade of recognizing kind of the starting point of different systems when we're thinking about restoration, and not, you know, lumping every stream into the same category, but thinking about what a reasonable endpoint might be given where we're starting. I mean, looking at the photos of the concrete streams in California, it's not the same thing, but in Minnesota, we have agricultural ditches that have been, I mean, possibly irreparably changed from what they were. So I think it's important to think about where they are now? I mean, can you restore a system like that where it provides at least a base level of some sort of natural ecological function or ecological services, versus if you're starting with a more minimally impacted system, can you restore it to something that would be considered a reference condition or pristine? So thinking about the starting place.
So yeah, Matt keeps stealing a lot of my answers. But just to add to that, I mean, I think that's one of the fundamental questions is what are we restoring to, and how do we build resiliency into those types of designs? So understanding how a system will respond and trying to plan for that response in the future, or allowing your systems, your restorations to respond to changing environmental conditions.
Good question online. Question online, please go ahead.
So kind of going off of that last point, one of our questions online is thinking of how changes in an ecosystem affects assessment of impairment. Have we found a way to measure resilience? As ecosystems change, what would be the optimal replacement system that reflects ability to recover function?
Who wants to jump in?
That's
on
a
that
fantastic
first?
question.
That's a
but-
really good question.
You want me to take first cracks at it?
Yeah.
You're the restoration expert, so I was waiting for you.
Okay, first of all, kudos to the online questioner. So yeah, really good question. And I like the theme that we're going with restoration related stuff. So I'm going to move away from streams because we have a lot of confounding factors between flood control and other types of natural things that can cause shifting baselines. For us, a lot of it is wildfire. So wildfire can just change the landscape in a heartbeat. So I don't really want to talk about that part. Where we're kind of building in resiliency is in our coastal areas. And so while it's not, we haven't been talking about it today, it's a big deal for us because of coastal water quality as well as sea level rise. And that's one where there has been a lot of work done on restoration and what kind of works and what doesn't work. We know what used to be there and what's not there anymore. And so people are truly planning for sea level rise because we already know it's happening. And we have some pretty good models on how high the sea could rise. So, and it really falls into three categories. You can either do build some hard structure like a seawall, and that'll hopefully protect the properties, but there's zero resilience. Right? The second option is what we call managed retreat, which is you basically sacrifice all the properties at the coastline, let them flood, tear them down, and just let the ocean do its will. So that can work, but of course the people that live in those places don't like that idea. So the third is what we call type conversion, which is you allow the sea level to rise, but you just expect maybe your mud flat to turn into subtidal, deeper water. And so that's the one that most people are going to because it's just the most palatable to folks. So what most of the restoration experts have been doing is finding out ways to, do you just let it flood and do its thing? Or do you actually try to raise the seabed essentially and keep a mud flat? And so that has all kinds of implications about where you get the extra mud from, what the quality of that mud is like, so you're not polluting that site. But it's very clear those systems are super resilient because they're used to dynamic, waves and storms, and we can have stuff come back in a hurry, including threatened and endangered species. So, so great question.
What about from our local panelists? Any ideas on that?
I'm looking to the folks with perhaps some practical expertise.
I would say, I mean, you mentioned building a seawall. I mean, it seems to me that building or trying to engineer ecological resistance or ecological resilience, excuse me,
Yeah.
sounds to me like concrete or large rocks. I mean, it's difficult to build natural systems that are resilient, I think. I mean, perhaps more so in systems that are used to large scale disturbances in your watershed, but in places that are not used to large scale disturbances, building in ecological resilience seems hard. Yeah.
I think there's a difference between resilience and resistance. And so
yeah.
something that is concrete and armoring a system, that would be you're resisting change. And resilience to me is more being able to respond to change or being able to respond to perturbations to the system. So it's a very different way of thinking of the system, allowing the system to change and respond as opposed to armoring it and holding it in place.
Yeah, that's
At least in my perspective,
that's a great point. I was thinking more in terms of really large scale disturbances like from climate change and that sort of thing, but it's a great point.
To me, because I'm not working in that area, but at least I think system used to solve this problem need to locally, and some construction if you're doing may impact our system, disturbing our system. Maybe a causal of system like a fish biological system will impact. So I think we should use kind of I don't know, maybe called ecological friendly system, something like this. Maybe it's a good idea to me. So
that's good. I want to dive in back a little bit to expectations, right? So thinking about expectations, what should we expect out of some of these streams that are, or lakes or other resources that we impact? And then what do we take them back to, right? We talked about reference and what is maybe that reference shifts. But I want to take that another step. And now how do we effectively communicate our changed expectations back to the public or decision makers, right? Because everybody has their own perspective of what it should look like. How do we kind of manage those expectations of the public, of the decision makers, of policymakers even? So I'll leave that open and you can dive into any parts of that you'd like.
After you deal with the public a lot, so.
I deal with the public a lot. Depending on the system that you're starting from, that can be an easy thing to communicate or something that's very hard. So if you're starting with a system that's already been severely impacted, like an agricultural drainage ditch or something like that, adjusting those expectations to what you might restore it to might be an easier conversation than when you're starting with a lake system that perhaps had better water quality, but has seen some major degradation due to whatever development in the watershed. There, the expectations for restoration are much higher, and so it becomes a more difficult conversation. And a lot of it too, I think, boils down to educating the public about what a healthy ecological system in each one of those systems looks like. I think oftentimes those expectations start out being unrealistic. Yeah, I'll leave it there.
That's
good. But Council is a public agency. So what we do, because we try to provide technical support for our local authority and the state level for decision making. So any study or result will try to customize to based on different audience. And for example, we have partner local watershed level. So we have a state level. And so, for example, maybe back to my Kozarek project example. So, and this work on the individual watershed. So in the watershed level, we prepare the partner memo. This memo have detailed technology because watershed have engineering, decision making, or manager. So give the detailed information how your watershed, what's happened, what's problem. So we have a called partner memo. And also for state level, we prepare the regional, from a regional point of view of a report. for decision making for region to say how, from the regional point of view, how it looks like your water quality, including your other traditional parameter and chloride. And also, like you say, for education public, we think the chloride is a public issue, not by the decision maker only. So we prepare this fact sheet, 2-page fact sheet. Most is including what's the issue now chloride, what's major our report. And but we include a lot of information, just basic information for education purpose. So that's why we have doing a different level of complication to try to transfer our result, our technology, our information to a different audience. That's what we did now. I think so far, I believe it's very successful.
That's great.
And also we're doing the conference presentation. We're doing the national or local conference presentation. So
Yeah, I think it's obviously important to get the information out in multiple ways, right? And for multiple different types of audiences. Other thoughts on that? Yeah.
You know, I would say this question of what it should look like, you know, the values, people's values vary dramatically. And I think the communication has to be a two-way street as well, in that it's not just us as, in my particular role as a scientist, saying this is what it should look like, but also listening to the community in terms of what is it about that system that they value in terms of water quality and everything else, and incorporating that when you're thinking about restoration and design.
All right. Well, obviously, this is a big deal for us. Out of the 4 kind of tips and techniques and tricks, it was dialogue was the 4th, right? So we spend a lot of time on it, on getting the communication. Our focus at our agency is communication amongst managers, the decision makers. We don't have a mandate or a goal to communicate with the public. Not that we don't try, and not that we're not open to it, but they're not our primary audience, which is why I let all these folks go first. So let me talk about communication on, if we're going to change a water body, what's it going to change into? The first thing you need to know about California is we established different beneficial uses for a water body. That's the coined term, a beneficial use, but that could be anything from agro-industrial water. It could be swimming, could be aquatic life, could be fishing. There's lots of different beneficial uses for almost all of our water bodies, and they're de facto already prioritized. These are really good for, beaches are really good for swimming, right? And we're not going to use that. Nobody had designed it for desalination. So, and then we have a second part of our water code, which is called anti-degradation. Even if it's not really designed, we haven't de facto kind of prioritized this beneficial use, you can't let the other beneficial uses get worse. And so that often comes up in our conversations about what do we want something to be, which is also what don't we want it to be. So, and then the last part is something I also talked about during my presentation, which is about that kind of working together to develop that technology. In this case, it's the assessment tools. That's because the beneficial uses and even the anti-degradation are almost all narrative. They're like, we want it to be this, we don't want it to get worse. But this is where the argument comes in, because one person's worse is not the other person's worse, or one thing's better is not the other person's better. And so that's where the assessment tools like our bug index or our algae index or our physical habitat index, those come in really handy, because these are technically robust tools that work in lots of different places, and that, a good, a score of 0.8 out of 1 means the same thing in one of those high mountains as it does on the floodplain. And so it serves as that communication tool. We do it mostly with managers. I'll tell you, they take the same thing and say it to the public. So that's how we do it.
We have some time for a few more questions. So if you have questions online, yeah, go ahead, please.
One of our online questions is, do your local programs integrate low impact development technologies like large rain gardens or living machines?
I could say at the watershed district scale, yes, absolutely. I mean, that's a big part of what watershed districts do. Yeah, watershed districts typically have monitoring programs, as ours do, and using that information to try and inform restoration work, where to put on the ground BMPs, stormwater BMPs like that. That's a big part of what a watershed district does. I think it's a struggle for us and probably for others to effectively try and link the monitoring programs with effective restoration programs. Where do you target? Where do you get the most bang for your buck in terms of pollutant removal? Yeah, that was kind of related to the question earlier about, in California, do you feel like those monitoring programs are effectively informing the restoration work? Is there a good link there?
So I think but Council is really just promote low impact development and not really work on, but we have promoted a lot. Our partner Watershed District also, I think when I remember when I did SWOT modeling for Watershed, when our BMP and I set in my model to study how stormwater change, pollutant changes, just set of low impact some parameter in. So I think this is required by the local and 30 some code. And I'm serve as a environment committee member for my 30 and the show view. So, and we talk about development or community house building development. We always talk about and low impact development design and something like, I think it's really local talk a lot about this low impact development. So
I'm going to pass this question on to you.
Okay.
Could you reread the question, please?
Do your local programs integrate low impact development technologies like large rain gardens or living machines?
Okay, so the answer to that is definitely yes. Southern California had some of the very first municipal stormwater permits in the country. And through the 3 decades that we've been doing it now, we've seen lots of changes in approach, both how it's regulated and how to respond. And now there's a huge push on LID and other types of both structural and non-structural BMPs. They've gotten to the point where they've passed county tax for property taxes voted by the citizens, and it's hundreds of millions of dollars a year invested in just the building, the implementation of these things. So that doesn't, they're expecting it to cost billions over the next 20 years. So so lots of investment in that, and we'll see if it works. They're big on adaptive watershed management, which I understand is a big term here as well. So this is where the monitoring stuff and the monitoring technology comes in to see if they're actually making changes, these things. So cool.
Yeah, maybe I'll emphasize that a little bit. That's kind of the whole purpose of adaptive management, right? With our TMDLs is we want to implement things, look for improvements. If we're not seeing what we expect, then we implement more things and we adapt and change. And that could be low impact development. It could be source control and reduction strategies. It could be a number of things. So we're trying to do all of those things. We are shortly running out of time. So I'm actually going to move us into our closing question. And this is a question for each of our panelists. What I'm going to ask is, what are your key takeaways from today? Is there anything that you would like to re-emphasize or re-highlight from the discussion that you want to make sure that our practitioners can take with them through the rest of the day and the weeks and months to come? Or is there something that we didn't get to cover that you really want to highlight and give to them as a tool or a resource that they can use? Or is there any other point that you want to make before we close this panel? So we're going to start again in the same order that I introduced. So Matt, please go away with what are your key takeaways today?
Yeah, it's interesting to see a lot of similarities, I think, between what we saw from Ken and what's happening here in Minnesota. I think there are some lessons to be learned in Minnesota for better integrating our assessment tools so that the ecological side of things, that's the fish IBI or invertebrate IBI or now plants and lakes, that those are better linked and perhaps more formally linked with the other assessment tools for chemistry and physical things, especially as we're looking at restoration projects and being able to want to demonstrate that we are making progress and things are changing. You know, on a shorter time scale, you can demonstrate that with improved habitat. You can measure that with various tools or improved chemistry. But for full ecological recovery or seeing improvements in IBI scores might take longer, or it might take further intervention because things have been fragmented and we have these biological deserts, I think was the term, which I like.
That's great. Thank you, Matt. Thank you. Hong, what would be your key takeaways today for our audience?
Yeah, I learned a lot today from the California's job. I think now, as you say, we spend a lot of money, public money to do an investment, take sample, but technology is very important. So like an index, you use complicated system. And so we think for the professional takeaway is before you're doing project, choose a better and the right technology for you to do your assessment to save time, to save public money. And for public, of course, I'm taking this opportunity to promote chloride management. So, and I think, like I said, chloride is just a pollutant, permanent pollutant as soon as enter the water and cannot remove. So, and the people need to pay attention now. As soon now, we in the metro area, we have a few well drinking water or test salt. So it's not a big issue. It's already a big issue. Also already impact, like you say, if we have more salt in the water, house biological community, house field, that's not really comfortable. And we also have in metro area, we have 3 streams have impaired by the chloride. So it's the issue. Now we just try to push people, say, okay, you need to pay attention, no matter from house food public, from the manager, from the estates management, you pay attention action now.
That's great. Jess, what would be your key takeaways?
Yeah, so I want to say thank you to everyone for the excellent questions. I really enjoyed this conversation. I learned a lot in this discussion, and I think my key takeaway, my personal key takeaway is that I really value discussions like this because it helps us as scientists better frame the kinds of research questions that are out there from the practical world and how we can help further along the practice. So.
That's great. Ken, you get the last word.
I get the last word. I had the first word and the last word.
First word and the last word. Yep.
Just the way I like it. So, well, I had a couple of takeaways. The first one, of course, is chloride's a big deal here. We have different sources, still a big deal. No, the main takeaway that I got is there's really active, engaged people here in Minnesota. And these are people that really care about their environment and care about doing well and keeping it a healthy environment for themselves and for their future generations. So that was really impressed upon me today. So the key takeaway, I'm hoping that all the folks that'll take both online and in the room were the same 4 that I said stressed during my talk. Working together is the key to making progress, right? And working together is the way you get context about what is really needs to be done, you know, where things are really bad and maybe not so bad. And the second thing, working together will save you money. The working together is the way to bridge that technology development, right? And test out things that are better, faster, cheaper. And then the last one is the dialogue, because the dialogue is the thing that leads to the decisions. If people just do it in their silos, stuff doesn't happen. So that's what I thank you all for coming today and listening to us. And thank you to my other panel members.
Yeah, very good. Thank you, Ken. Thank you for those. So close, I want to thank the online audience, the in-person audience for joining us today for the Minnesota Stormwater Seminar Series. We didn't get to talk about chloride too much, but spoiler alert, we will have a seminar on chloride coming up. So that discussion will continue and there will be resources to share on that. For now, though, again, thank you for joining us today. Thank you to our keynote speaker, Ken, for setting the topic. Thank you for our local panelists for tackling some difficult questions. I never said they'd be easy questions, right? So, and thank you to the audience for asking such great questions. I look forward to seeing you at a future Minnesota Stormwater Seminar Series. Thanks and have a great day.
Thank you.